Hello, I am Adam Albash, and this is my weather trend forecasting project for the PM Accelerator Data Science Assessment. So first of all, I went over the data set. It had no missing values. It had 33,000 records, 48 features, include 211 countries and 257 cities. I did a brief data cleaning process. However, as I said, there were no missing values, so I quickly moved on to a little bit of feature engineering outlier detection. Basically, I found that there were several outliers, about 6,000, but however, I kept them because those represented significant weather events that were happening. After that, I went on to the exploratory data analysis, where basically what I did was I analyzed the temperature, precipitation, specific correlations, and patterns. And basically, we can see that, for example, for temperature, we had a mean temperature of about 22 degrees, was 21.3. We had also specific seasonal trends dependent on the hemisphere in the Earth. We also found that the precipitation was specifically right skewed, and its distribution was skewed. Also did a correlation heat map for the features and found, for example, a specific feature such as the temperature very closely related with what it feels like. Also, we found that the gust and the wind speed was also very closely related. Also did the other temperature trends analysis, and then I moved on to the anomaly detection. As I said before, I found about 6,000 anomalies. The code for that is right here, so it's here. Almost 6,000 anomalies, which is about 5% of our data set, and it represented extreme weather events with unusual feature combinations, and those were scattered differently with different values. After that, I used basically developed specific models for forecasting. That was Sarima, Profit, XGBoost, and LSTM, as well an ensemble between them, which outperformed all the individual models and given us a MAPE metric of 75%. After that, I also did a little bit of analysis of the feature importance, and the code for that is right after the models. The code for that is down here after the model comparison for the feature importance analysis. Yeah. So basically, we found that I tried to find which specific features are most important, and we found that the fields like latitude and UV index are the strongest temperature predictors. And I also did a little bit of regional patterns dependent on the continents. For example, Africa and South America were the warmest, and while Europe had the widest seasonal variation. And also the environmental impact of air quality versus the weather. Basically, I found that wind disperses pollutants and temperature increases the ozone via photochemical reactions. This is some more analysis, geographical and spatial. Basically, we had that latitude temperature gradient. We can see right here. Also, the equatorial regions, which are the warmest, and also how the poles, north and south pole,